In the last episode, our programs learned how to work with collections of information. We worked with lists, and lists gave us a way to store multiple values together. But real engineering systems have a different challenge. They don't just store information, they store information that means something. Let's say battery is equal 18, and then temperature is equal to 42, and then GPS is equal to online. You can imagine this is a drone that is sending us three values. If I say print battery, and then I would say print temperature, and I say print GPS. Let me just save this and run the code. So it'll be Python 3 dictionaries. Okay, 1842, and then online. Now, let me ask you a question. Can you tell me, without seeing the code right now, imagine this code is just behind the scene and all you're seeing is these three values. Would you know what these values represent? Probably not. Maybe 18 is a battery level, or maybe the 42 is the battery level, and then the temperature is 18. What is online? Is it for GPS, or what is it for? You'll be guessing those values. The information exists, but the meaning is missing. And that's a huge problem because software doesn't just work with data, it works with meaningful data. And that's exactly why dictionaries were invented. Today, we're going to learn one of the most important structures in all of programming, a structure that allows us to connect information with meaning, and that is dictionary. So let's build our first dictionary from scratch so you can see the difference between this and dictionary structure. You'll see a huge difference because right now, remember this, what you're seeing is only that data, and that data is working, the machine is working, but it's kind of meaningless. Or if I ask you what this represents, or any other machine is asking what is 18 is representing, if I want to interact this code with another machine and the other machine is asking, hey, what does 18 means, or what that data represent, you would have a challenge to understand what is this data meaning, because you'll have thousands of these values and probably multiple sensors sending different types of data. So not a good way of creating a code. But with dictionaries, you can resolve that issue, and we'll see that. Let me just remove this right now, okay? And I'll just clear this out, okay? I'm going to create a variable, and that variable, I'm going to call it a drone state, okay? Because this variable will represent the current state of a drone. And watch this carefully. I'm going to create curly braces. See the difference between this and lists? With lists, we build those brackets, which is like if I would say drone state variable, it would be like this, okay? I'm not doing that here. All right, and I'll tell you why this is, what's the difference between dictionaries and lists. Drone state is the variable. Then I will create something, we call it as keys and values. So we'll have battery, and I will give it 18 like this. So instead of storing only a value, we start with a label. We call that label battery, and this label is called a key. And after the colon, which is the 18, we store the value. So we have keys and values, and that's what all dictionary are about. So now we're not just storing the number 18, we're telling Python exactly what that number represents, which is the battery level. I'm going to add another one. I'm going to say temperature, and then I'll do the same thing, 42. So we just added another piece of information. Temperature, notice the pattern. We have the key, colon, and value. This simple pattern is the foundation of dictionaries. So let's add also the GPS status. So here's what I'm going to do. Okay, I need to remove this, put up this comma. I'm going to add the GPS value. And notice the GPS here. Okay, same pattern. And then here I will say online. Notice something important. The value here online doesn't have to be a number. It can also be text. Dictionaries can store different types of information together, numbers, text, and later we will see many other types as well. So now our first dictionary is complete. Let's see what we built. So let's just say print drone state, Command S, so I can just save it, run it. Look at the difference. Earlier, we only had 1842 online, if you remember. Now, every value has meaning attached to it. The battery is 18, the temperature is 42, and GPS is showing as online. That's the entire purpose of dictionaries. They allow software to describe reality. A drone, a vehicle, a user. In the future, we're going to do telemetry packets, anything that has properties and information. And once software can represent reality, it can start making intelligent decisions about it. Now we created our first dictionary from scratch. It has 3 different information or pieces of information, but that's half of the story. Eventually, we need to use that information. Let's say our drone wants to know its battery level. How do we get it? How can I call one of this data or all of these data? Or, all of them, we just print it and then we show all of them. But what if I want to call the temperature value here, 42? Can I do that? So Python stored 3 pieces of information: battery, temperature, GPS, and each piece of information has a key attached to it. So instead of asking for information by position, which is before what we used to do, if I say, for example, drone, same thing, state, let me just call it list, okay, as a variable. And then I would say 43, and then I would say 33, right? If I say print, okay, drone state list, okay, and then I would say 1, if I run this right now, it should give me 43. Why? Because I'm calling the position 1, which is 0, 1. So I'm calling the position. Now, can I do that with dictionaries? The answer, you can't do it by calling it this way. It's going to be a different mechanism. So we're going to ask for information by name. Let's delete this. And it's the same thing pretty much. Drone. And then I would open a bracket, I would see battery, GPS, temperature. So I can call any of these values. So if I say battery, and then I would just run it. So first, I write the dictionary name, then square brackets, and inside the brackets, I write the key that I want, which is battery or temperature or GPS or whatever the key that you have inside the drone state variable or any variable that you create. I'm literally telling Python, go into the dictionary here, okay? Go inside the dictionary that is called drone state and find the value attached to battery. If I call here temperature, and then I Command S, and then here I would just run it. It's going to give me 42. So all I'm doing here, I'm just saying inside the drone state, there's a key that is called temperature. Give me the value of that key, temperature. And here you go. It's 42. So Python searched for the key, found the matching value, and returned the value that this key assigned to, whether if it's 18 or 42 or the GPS here is showing online. Notice something important. We didn't need to know where the value was stored. We only needed to know its name. That's one of the biggest advantages of dictionaries. We saw that battery gives us a number, temperature gives us a number, you have GPS gives us a text, and we'll see much more different types of data that dictionary can take. Python handle all of them the same way. Find the key, return the value. Let's make this feel a little bit more realistic. Imagine this battery value that we came up with, which is 18%, came from a real drone. If the drone reports 18% battery, that's not a good thing. We might want to warn the operator or maybe send the drone home or to the station. So we have to do something for the drone. Otherwise, we're going to lose contact with this drone because the battery is going to drain and maybe the drone is going to shut down. So maybe we can send the drone home or warn the operator. To make decisions like that, we need to compare values. And this is where dictionaries become much more interesting. Okay, so now our dictionary represents some kind of a snapshot, okay, of a reality. You got 18% battery, you got 42 temperature, GPS online. This is not something that is running in real time, but if you have a drone, all these information are changeable. If the drone is moving, GPS is actually changing. You got the temperature is constantly changing, the battery level is changing. How do we update information that's already inside a dictionary? Imagine the drone keeps flying for a few more minutes. The battery drops from 18% to 15%. How do we tell Python the drone in reality has changed from 18% to 15%? Maybe we can just remove this, and then we're going to say drone state, and then I'm going to call the key battery, and then I'll just say the value of that key is equal to 15. Let me print the variable drone state and let's see the battery value. I'm going to print the whole drone state dictionary. Here you go. You got battery is reading 15. What we did is first we identify what we want to update, which is inside the dictionary, pointing directly at the battery value, and we use the equal sign. What we're saying with the equal sign, it's not to compare, it's to replace. We're telling Python, take whatever value is currently attached to battery and replace it with 15, or whatever the value that you're using. The battery now, as you can see, has changed, but everything else stayed exactly the same. Temperature is still 42, GPS still showing online. We updated only one piece of information, and that's incredibly important. Real systems rarely rebuild everything. They continuously update small pieces of information. Let's simulate another update. Maybe the drone cools down and the temperature drops. It drops from 42 to 35. So same thing, I would just say drone state, and then I would call temperature, and then I would say the temperature is now 35. Command S, and then I would just run it. Now both values have changed. Our dictionary starting to behave like a real system. A reality changes, our model of reality changes as well. And that's one of the most important ideas in software engineering. Software isn't a reality, it's a model of reality. And the better we keep that model updated, the better decisions the software can make. There's something even more interesting. We're not limited to updating existing information. We can also add entirely new information. For example, maybe our drone starts reporting altitude, which is a very important information that you need or the drone needs. Or for example, signal strength. And dictionary can make that easily. All right, so let's add the altitude key and value. Notice what I'm going to do here. I'm going to say drone state, and then I will just say altitude equal to 120. Notice something interesting. We're using exactly the same syntax as we use when we are updating a value, but the only difference here is notice that the altitude does not exist in the dictionary. But what I did is I called the dictionary and then I created, that's what Python is doing. It's automatically creating an altitude key, and then I'm assigning, or Python assigning whatever value that is connected with that key. Let's see if that actually what happened. Here we go. We have altitude is 120. So Python creates it automatically and assigns the value 120 to that key, which is the altitude. Let's add one more key. So in real drones, often have different flight modes. So let's see if we can add a flight mode key. And with flight modes, for example, it could be manual, automatic, return to home. Just for the sake of example, we'll just say, for example, drone state, same thing. And then I will just say flight mode, and then I'll give it a value. And here I'll just give it a text value. I'll just say auto. Okay. Command S. Let's run this. Here we go. Now we have battery, temperature, GPS, altitude, and flight mode, which is auto. Now our model is becoming much richer. It doesn't just know battery or temperature. Now we added altitude, flight mode. We can keep growing this structure as the system grows. And this is exactly what happened in real engineering system. A product starts simple, then new sensors are added. So therefore, where new features are added, you'll see that the data is evolving, and therefore basically the software is evolving alongside to it. Let's get back and see what we've done so far. We created a dictionary, and dictionary now is storing information using keys and values. Keys, let's say battery, and then the values 18, and so on and so forth. We can also we learned also how to retrieve information using the key. Let's say we call the battery, and then we can change the value from 18 to 15, or temperature from 42 to 35. We can update those existing information. Also, now we can add entirely new information. Python automatically created this key and then the value assigned to it. So our dictionary is becoming a living model of a real system. Up until now, our dictionary has been acting like memory. It stores information about the drone. But storing information is only the first step. The real value comes when software starts making decisions based on that information. Let's see what that looks like. First, let's just clean this up. I want to keep the example as simple as possible. So we'll change the battery to 15, and I'll tell you why. And then we'll change the temperature to 35. I'm just writing everything in the drone state dictionary. Altitude would be 120, and then flight mode would be auto. Okay, so let's imagine this is a real drone with real data coming at a certain time, at a particular point. The battery of the drone is reading 15%, and temperature is 35, GPS is online at an altitude of 120, and the flight mode is auto. The problem here is battery is reading 15%. The drone realizes that 50% is too low, so maybe we should go back to the base and charge the battery. So how can the software of the drone recognize that situation automatically? We can do this by combining conditions with dictionary data with this variable. So let's do that. Okay, so let's do this. First, we're going to say if, and then I'll be calling the drone state. And in the drone state, I'm going to be calling the battery because that's the one that I'm trying to make a condition for it. If the drone state, or if the battery level is reading less than 20%, then I want you to print return to the base. So let's do that. Return to the base. Let's read this slowly. First, we retrieve the battery level from the dictionary. Python looks for the battery key and returns the value attached to it. And the battery key here is 15%. So it's going to go here and says if 15% is less than 20, then print that. And if that condition is true, then it's going to return to the base. So my question is, if is 15 less than 20? The answer is yes. So then this is going to be true. So if you run this, we should get this action. Here you go. Now we're telling the drone what action to take. If the battery falls below 20%, return to the base. Very simple rule, but simple rules are the foundation of many real systems. Notice what just happened. The dictionary stored information, the condition evaluated that information, and the software generated an action. That's the beginning of intelligence. This is a very simple example, but with more data and more logic, we're going to be building more advanced intelligent systems. That's the beginning of intelligence. Observe, evaluate, then act. Let's add another safety check. Suppose we want to detect overheating. Okay, so the temperature here is 35. Many drones, vehicles, and embedded systems monitor temperature constantly because excessive heat can damage hardware. So the same idea, we're going to add also the if condition, but it's going to be looking for a different key. So we'll be saying if the drone state, and here I'm going to be calling what? Temperature. Okay, if the temperature is greater than 40, then I will say return to me or print overheating detected. So here, what I'm doing, same idea, different key. We retrieve temperature from the dictionary and ask the question, is temperature greater than 40? If yes, then generate that warning, overheating detected. But right now, our temperature is 35. As you can see here, it's reading 35. So if I run this code, it's going to check the temperature and ask the question, is temperature, which is 35, greater than 40? The answer is no, then this will not run. So if I change the temperature of the drone to, let's say, I'm going to say drone state, and here I'm going to call the temperature is equal to 45. But before I run this, let me just comment it. Let me just run this first and show you what we get. Okay, so we didn't get the overheating detected. Why? Because it's reading temperature as 35 and it's asking the question, is 35 greater than 40? No, then don't print this action. Now I'm gonna keep this. Now the temperature is reading 45. So if I save this and then run the code again, here we go. Overheating detected. Why? It's going here, asking the question, is temperature, which is right now is 45, greater than 40? The answer is yes. Then print overheating detected. Look at what we've built so far. We started with a dictionary, then we retrieved values, we updated values, we also added new values to the dictionary, and now we're using those values to make decisions. That's a huge step forward because software is no longer just storing information here. It's starting to reason about information. Right now, our drone can make decisions, it can detect low battery, it can detect overheating, but we've got a new problem. Imagine we have 10 drones, or 100, or even an entire fleet of drones. Do we really want to rewrite these checks over and over again? Probably not. Earlier in the roadmap, we learned a tool specifically designed to solve this kind of problem, which is called functions. A function allows us to package behavior once and reuse that behavior whenever you need it. So let's build a function that can check this. We can call it health check system for all drones, not just for one drone. So let's clean this first. And I'm going to remove this and keep this information, which is the variable. Just keep the variable. And then here, drone state temperature, I can remove this and just change it here just to make things simple. All right. And then I'm going to start with creating the function, which is, I'll call it health check. And then I'll give it a parameter called state. So let's start with the function definition. The word def, of course, tells Python we're creating a function. And I've named it health check because its job is to evaluate the health of a system. Notice something interesting. I didn't call the input drone state here. I didn't call this. I just called it state. Why? Because I don't want this function to work with only one specific drone. I want it to work with any state dictionary I give it, any kind of drone, any drone state. And that's what makes functions reusable. A good engineer doesn't build something for one situation or one experience. They build something that can be reused in many situations. So inside the function, we're going to do the if conditions, which is we're going to say if the state, and then inside the state, I'm just going to call the battery less than 20, then print, same thing, return to base. And then I'll just say if, I'll do the same thing, state temperature is greater than 45, print overheating detected. Okay, so we're writing the exact same logic we created earlier, but now it's packaged inside a reusable tool. I call it function. So let's read this. First, state battery. We retrieve the battery value. Then we ask the question, is battery below 20%? If it's yes, then print a warning, like the one that we put, which is return to the base. Then we added the temperature check as well. Same pattern, retrieve the information, evaluate that information, and generate an action, which is if it's over 45%, then send the warning overheating detected. Observe, evaluate, and act. That's the kind of foundation of most systems. The function is complete, but nothing happened yet. Defining a function right now, what we just created, if we can't really run it. Defining a function doesn't really run it. It simply teaches Python how to perform the task. To actually run or use the function, we need to call it. So how do we call the function? To do that, we're just going to do health. See here, I can see health check. I can see the function. Okay, so I'm going to call the function. Inside the function, I'm going to call drone, as you can see here, drone state, which is I'm calling this dictionary. So what I did here, we're passing our entire dictionary into the function. The function receives that dictionary, checks the battery, checks the temperature, and decides whether the drone is healthy or not. Let's run it and see what happened. All right. As you can see here, return to the base. Why? Because it's going inside the function, it's checking the conditions. Is the battery is less than 20, 15 less than 20? No, then return to the base. And then in the same time, check the temperature. Is the temperature 45? Yes. Is it greater than 45? No, then don't send this condition. So if I change this, if I change the condition here to, let's say, 40, and then I run this again, I will get the drone right now is returning to the base, and it's also overheating is detected. So look at what we just built. A few minutes ago, we had a dictionary, then we had conditions, and now we've created a reusable health check engine. Anytime we want to evaluate a drone, we simply pass its state into the function, and the function will do the rest. This is where programming starts becoming engineering. And instead of writing code once, we build systems that can be reused. Our health check works, but there's one limitation. We've only been monitoring a single drone, and real systems rarely stop at one device. Maybe we're monitoring 10 drones, 100 vehicles, and thousands of IoT devices. So how do we manage multiple systems efficiently? Let's see if we can do that. Maybe we can handle multiple drones, multiple IoT devices. But since we had an example about drones, let's see if we can build a fleet of drones, basically 3 drones, let's say. So I'm going to clear this out. I'm going to create a variable called fleet, and that variable is going to be a list. And if you don't understand anything about list, you can watch the previous video. It should be very helpful. Inside the list, I'm going to create a dictionary, and inside that dictionary, okay, there's going to be ID, and here I'm going to call drone 1, and then I will create another dictionary, and then here I will just call ID, and then I will call it drone 02, and then also I will call create another dictionary, and then call it ID, and then call it drone 03. I just showed you that, okay, now we have 3 drones. And then inside each dictionary, I'm just going to create the battery level, which is here is going to be like 13 or 18. And then I'm also going to create maybe temperature, same thing. And then here I'll just give it 45. And then same thing for this one, battery 82. And then I will also create temperature 30. And then for the drone 3, I will create, again, battery, 12, temperature, 35. Let's go slowly here, okay? Let's start from the beginning. We created a variable called fleet, and the square brackets here tells us we're creating a list. And inside the list, we're placing dictionaries. Each dictionary is representing one drone. We now have a collection of systems, not just one system. We have multiple systems. This is a common pattern in programming, a list of dictionaries, and you'll see it everywhere. Let's run this. If I say here, just print fleet, okay? I can see it right here, okay. Look at what we built. The list represents the fleet. Each dictionary is representing what? Each dictionary is representing the state of one drone. So we have information about multiple systems stored in one structure, and that structure is basically called fleet. Now let's inspect them one at a time. Can we do that? And the answer is yes. So if we say for drone in fleet, print drone. Let's save this and let's see what we get. The loop here will visit each drone in the fleet. Okay, it'll go one by one dictionary at a time. And watch what's happening. The loop grabs the first drone, prints it, move to the second one, prints it, then the third. This is exactly the same loop concept we've already learned in the previous video, which you can watch that video about for loops. But now we're looping through dictionaries, and that's incredibly powerful. Let's make the loop something useful. And instead of printing every drone, let's automatically find drones with, let's say, low battery. I can do that. So if I say for drone and fleet, I can keep that, and I can say if the drone with battery that is less than 20%, print, call that drone and call its ID. Okay, I'm just calling the ID of that drone, and I will say here, just say need charging, something like that. So if we print this, we have drone 1 needs charging and drone 3 needs charging. Why? Because which drone that has battery level that is less than 20? Drone 3 and then drone number 1. Okay, so let's give a summary of what we just did. So we have 3 different drones. We created a for loop, and we set it a condition where if the battery for any of these drones reaches below 20%, then send me some kind of alert or saying something like needs charging, or maybe like, for example, return to base, something like that. And if that is the case, I need you to print the ID of that drone so I can identify which drone I need to return to the base. And then when we printed that, what we get is drone 1 and drone 3. Why? Is because one is battery is 18%, the other one is 12%. For that one is 82%, is fine. So I can add another condition here, and I say if, for example, the drone, here I'll just say temperature greater than 40, then print overheat detected. And also I can just say, therefore, I don't know, return to base or do something else. Okay, so then I'll print this, and then there's one drone that I don't know what it is. So one thing I can do here, I can just say, okay, well, I'll just say drone. I'm calling the index inside the fleet, and I'm just saying, call me the ID of that drone. Okay. All right, so let's clear this and let's print it again. Here we go. So we have what? We have overheat detected, return to base, drone 1. Why? Because a drone 1 is the only one that its temperature is 45%. And since we also learned about functions, we can just literally go back to our function, which is the health check, and then we can just keep everything health check, and we can even call the parameter state, fleet, whatever. And then here we can just push that inside the function. And then now if we want to call the function by just calling the health check function, and then inside we're going to call what? We're going to call the fleet, because that's the parameter that we need to check its health, basically, which include 3 drones. So let's run that. Let's save this. We're going to run this. Here we go. It's working. So up until now, each drone stored information like this. We have, let's say, very simple ID, which is drone 1. The battery of that drone is 18%. Its temperature is reading 45 at that particular point, at that particular position. But real drones are not simple. Real drones contain multiple systems. You have power system, you have a navigation system, communication system, you got the camera system, you got another other sensors that are included. So as engineers, we don't think about individual values. We think about systems. So instead of organizing data by values, we organize data by subsystems. Because you have, especially with drones, you got system within a system within a system. Let me show you what I mean by that. So for example, we're just gonna create a drone, and then we're gonna call the ID of that drone as drone 01. Okay, and we'll show, or we'll give it the value of power. Okay, so power, and then inside the power value there's 2 values. So in this case I will create battery level. So I just created another dictionary. Okay, so 50. And then also I will create voltage reading, which is in this case, let's say 12.1 volts. Okay, sounds good. So now you have the power has 2 values, battery and voltage. Okay, let me do another one. You got another one, which is navigation, for example. And inside the navigation, okay, I'm going to open another dictionary. I'm going to call GPS, and in this case it is reading online, and then maybe altitude, and let's say it's reading 250. Notice here there's a red because I'm missing the bracket. Notice something important. We no longer storing drone data. We are storing drone systems. You got the power system and you got the navigation system. So basically, if I want to show it to you here, you have a drone. This is drone 1. Okay, and then inside the drone there is 2 things. There's the power system, and then there is the navigation system. Okay, and then inside each one, okay, I'll just do it this way and then this way. Just very simple. Inside the power system, you have battery, and then you have voltage. Okay, and each one is reading something. And then also for navigation, you have GPS and you have altitude. So this is the diagram for what we have. Dictionary created 2 different variables. Each variable has its own variables. If we want to say, I want to access the battery level, I have to go and call drone number 1. Inside drone number 1, I need to call the power system. And then within the power system, I'm going to call the battery level in order for me to find out what's the battery for drone number 1. Same thing for GPS. If I want to identify the GPS, if it's online, invalid, whatever the reading at that particular time, at that particular position, I would have to call drone number 1. Within drone number 1, call navigation system, and then call the GPS. So you got this kind of like path. And this is called nested dictionary, which is basically you're calling a system within a system within a system. Let's see if we can actually run this and call, let's say, print drone. I'm calling right now. I'm calling drone. Okay. Inside the drone, I need to call what? The ID, or I need to call the navigation, for example. Okay. And then inside the navigation, I need to call the altitude. So I'll just say altitude. Let's run this and see if we get the altitude, which is supposed to be 250. Okay. We got an error because I got the altitude wrong. So let's do it again. Here we go, 250. Same thing if you want to call anything else. Let's say you want to call a drone, and then inside the drone, something within the power, and then I need you to call, let's say, the battery level. Okay, I want to check the battery of that particular drone. So I'm calling the power. Within the power, I need to call the battery. So this is supposed to print 50, right? So let's save it. Here we go. It's showing 50. We can even update the nested dictionary. And the way to do that, we can just say drone, okay? And then inside the drone, call the power. And then inside the power, I need the battery level is equal to, let's say, for example, the drone is charging from, it was, let's say 50, sorry, it was discharging because it is being used, and then it got dropped to 18%. So let's save that, and let's see if we can print now. After this gets executed, now I need to call drone, I need to call the power, and within the power, I need to call the battery level. Let's see if we can run this again. So I'm going to save that, and all right. So you can see that it's reading this updated battery level, and it's showing 18. So a nested dictionary allows us to organize information into systems and subsystems. You got the power, and inside the power, there's also subsystems, which is the battery level, the voltage, the current, and whatever information or values that you want to add for whatever the subsystem that you want to include. And instead of storing random values, we basically model the structure of the real machine. This same structure is used in everywhere: APIs, robotics, telematics, even medical devices, and large software platforms. In the beginning of this video, when we printed a list, we saw that the result was literally 18, 42, and online. We don't even know what 18 represent, 42, and online. And we asked that simple question: how do we know what these values represent? The question led us to dictionaries. And from there, we've learned how to create information, retrieve it, update it, expand those information, make decisions, build reusable systems, and even monitor the fleet that we did with drones. We organize subsystems, navigate complex structures. But underneath all of these examples, or those examples, there's a deeper idea. Software doesn't interact with reality directly. It builds models of reality. A drone becomes a dictionary. A vehicle becomes a dictionary. A telemetry packet becomes a dictionary. And once reality is represented inside software, the software can reason about it, make decisions, for example, generate alerts, trigger actions, and eventually power intelligent systems. And that's why dictionaries matter, not because they are a Python feature, but because they are one of the simplest ways software can describe the world. And when software can describe the world, it can start changing it. So next, we'll be exploring a structure that looks similar to a list, but follows a completely different philosophy, and that is tuples, immutable memory, or tuples, whatever you call it. But I'll see you guys in the next video. If you see any value from this video, give it a thumbs up, subscribe to the channel. If you have any questions, leave it in the comments, and I'll be happy to respond. Take care, everybody. Bye-bye. Bye-bye.